Okay, then I'll share my screen. Oh, separate. Okay, do you see my screen now?
Yes, sir. Visible, sir.
Okay. So today we'll start with module 3, which is on solving nonlinear equations. Okay, so before we get into solving nonlinear equations, the question arises, what is a nonlinear equation? So, for you guys, what is a nonlinear equation? Generally speaking, nonlinear equation, if you have a simple equation like this, let me write. Yeah, before I go there, are there any questions about what we did in the practice session 1 and practice session 2? Any questions? Are you, I'm telling you the exam is going to be on a computer. You should be able to do simple programs, kind of the programs I've done in the worksheet, in the notebook. So are you able to follow what is being taught? Is that a yes or a no? Did you guys attempt to play with that notebook that I sent you? What does it mean when you're not responding? No, at least one person. Maybe I'll take some names 1 second. I think because collective responsibility is then nobody takes responsibility. I'll call some names here. Okay, Mohan Krishna N. Mohan Krishna, you're there? Mohan Krishna, you'll have to unmute your mic and speak. Yes, I can see your hand, but I want you to unmute your mic and answer my question. Mohan, are you not able to unmute your mic? Mohan Krishna. Mohan Krishna, at least lower your hand. I don't need your hand. I'm not asking whether you're able to. Okay. So is it that you're not able to unmute your mic for whatever reason? Okay, we'll ask Pradyum Nasimha. I tried to talk with him earlier. Pradyum Nasimha. Pradyum Nasimha. Okay. Pawan Kalyan.
Yes, sir.
Okay. I meant other Pawan Kalyan, but it's okay. Pawan Kalyan. So did you try to run the notebook I sent you? So
What, sir?
did you try to run the program that I sent you? That I shared with you. Is that a no, Pawan Kalyan?
Sir?
Pawan Kalyan, did you try to run the program that I sent you? Hello? Pawan Kalyan.
Sir.
If it is a no, I can say no, Pawan Kalyan. Don't waste time like that. Did you do it or not?
No,
Hello?
no, sir.
Okay, that's good. That's good. No, only took time. Okay, we'll ask Rushita then. Rushita,
Yes, sir.
did you try to run the code I sent you?
Yes, sir.
So do you have any questions on that?
No, sir.
Do you have a laptop at home, Rushita?
Yes, sir.
Okay, did you install Python in it?
Yes, sir. I installed, sir. I'm running.
So are you running in Jupyter notebooks then? Did you try to run the program that I sent you in Jupyter notebook?
Yes, sir. I tried, sir.
Everything is working for you?
Yes, sir. Working, sir.
Did you try to change things and do it differently, do something different in the
Yes,
program?
sir. I tried, sir. But one doubt, sir. We can't add files, sir.
You can't add files in. Okay.
Not like that, sir. Oh, we'll give code like open file name, sir. File name equals to open some file name, sir. It is not
Okay.
opening, sir.
Okay. Is it a good time? Can you share your window with us so that I can look at it and see what you're trying to?
I'm using mobile, sir. No.
Okay. Okay. See, I think if you have friends from other departments, EC or Triple E, they may
Yes, sir.
no. I'm sorry, not EC Triple E, CSE or CSIT or some people like that. They may be
Yes,
able
sir.
to help you. What you're describing to me, it looks like a simple problem of knowing how to do that. Okay. But
No, sir.
how
In
will
normal Python, it is opening, sir. In Jupyter, it is not opening, sir.
okay,
I
the
have code
code I
blocks
sent
there.
you. Okay,
In,
okay, I
in code
understood.
block, it is opening, sir. But here, it is not opening, sir.
Yeah, yeah. Jupyter is little different. So, let me open my Jupyter. I'll show you. As you know, it will open in browser. Okay. Anyway, while that is opening, um, again, students, I'm telling you, the exam is going to be like the Python exam that you wrote in the first year. It will be in the lab. Okay. We'll give you a problem and you should be able to solve that problem by writing a program on a computer in the exam. So the exam will be conducted in a lab. So it's very important that you know how to do these programs. Okay, so this is my Jupyter. Okay, so these are the files. So one thing you could do is, Rishita, I think this is what you meant. You could say upload. If you want to know if you have downloaded the program somewhere. For example, the program I sent you, it is here. I think in classes. If I'm not mistaken, it should be not in this one. Okay, I'm trying to navigate to the location. See, I said upload, Rishita, in the
Yes,
Jupyter
sir.
one. I said upload, and then I'm navigating to the place where I have saved the file, which I think I'm not sure, but I think it has to be here. Fall 2020. Yeah. See, session one notebook and notebook two. This one, open. See, once I upload it, it will be in this, wherever you are running. I think there are other ways of doing it also, but this is a simple way you can run it. See, now it is here. So then you can open
Yes,
it.
sir. I open like this, sir. I'm not asking this one, sir. In code, if I give file name, it is not opening, sir.
So why are you trying to open files from the code?
No, sir. Not for our subject, sir. I'm doing another one project. In that I'm opening, it is not opening in this Jupyter course. In Coursera, they said.
Okay. Well, I think it is about how you are referencing the files. No, you whatever file that you are using, that also you have to upload here so that the
I
file
have
appears
uploaded
here.
it here, sir.
Okay, and then whenever you're opening the file, it is relative. I think, are you appropriately calling the file? Okay. Anyway, in this course also, we'll do some file input output operations. Okay, at that time I'll show you how to do the operations with the files. For example, here I can show you for this code. Yeah, there is micro learning underscore data, right? So here I can somewhere okay, I think I'll say data equals. For example, one of the thing is read underscore CSV. I don't know which one you are using, but okay, maybe I'm confused with the R now. Anyway, you have to give the reference here because it's in the same directory. You should be able to give the number name directly. What is that? Micro lending. Micro lending underscore data. Micro lending underscore data.csv. Lending. I remember. I think it is in pandas. So I have to import pandas. Import pandas as PD. I think this is pd.read csv. Okay. This is a little different, so I do that. It is running. Okay, so if you know pandas, I think you have to do head dot data. Oh, I think this is data dot head. See, I was able to read because it is in the same directory. All I had to do was directly give the name. Is able to read. Okay, anyway, I think we are digressing. So if you are able to run this Jupyter for the other people, if you have Jupyter, this is how you do it. You say upload and you navigate to the place wherever the file is saved and the file will show here. Then you should be able to open it. Again, I'm telling you this is not the only way. There are other ways you could do it, but this is one simple way that you can do it. Okay, so let me close this one. See, again, for those of you who have laptops and you have installed an account on your laptops, this is a second way. This is an alternate way of running Python using Jupyter notebooks. See, and whatever I'm sending you, you should be able to open them in Jupyter notebooks like this. Okay. Anyway, but those of you who don't have laptops, you still have to do it the way I'm doing it. See, the reason I'm using Colab is so that I think you will also know how exactly I'm doing it, and you should be able to do it from your mobile phones. So don't give an excuse like you don't have a computer. It is little bit, it's little bit more difficult to type the code when you're doing in the phone. I agree, but every one of you, okay, you take lot of time to do chatting on WhatsApp, right? Or Insta chat, Snapchat, whatever the nonsense you do. If you can invest time into doing those things, and if you don't mind typing you with your thumbs when you do WhatsApp and all, you should not mind at all having to write a program using your thumbs. Okay. In the end, you should know how to do this. And if there's any difficulty, you should let me know. Every single time I'm asking, because I don't want to hear that I don't know how to write a program. 2 weeks, 3 weeks down the line, I don't want to hear you tell that we don't know how to do the program. Is that understood? How many students are in the meeting today? Hmm, 17. Okay. Okay. So that being said, to me it's very obvious that many of you are not trying to write the program, or even though I have sent you the whole thing, at least one set of programs I've given it to you, right? All you have to do is try to understand how they're working, and more importantly, you should do your own practice. You should experiment with it. That's how you learn. No, you can change the program and see what happens. Change here and there. Oh, okay, that makes me curious. So, Rushita, what is the course you're taking on Coursera which needs Python programming?
Python using database. Database using Python, sir.
Ah, that's very good. So then pandas then.
Yes, sir.
Are you using pandas library in that course?
No, sir.
Okay. Okay, that's fine. Okay. No, but in the end, every single one of you should know how to write the program. Okay. Now we talk about nonlinear equations, and strictly speaking, okay, linear equations are simple. If you have an equation, oh, I need a pen again. Okay, if you have an equation like this, uh, for example, uh, conversion of temperature from Fahrenheit to degree centigrade, let's say. Then you say temperature in degree centigrade equals temperature in Fahrenheit. What is the conversion? I think it's 5/18 or something, right? Plus 32, I think, something like this. Okay, so this is a linear equation because you can think of this as the independent, this is the independent variable, this is a dependent variable, and the relationship is linear. Okay, no complication whatsoever. Okay, very straightforward equation. Now, very few equations are linear like this. Okay, here the independent variable is the dependent variable is a linear function of the independent variable. That's what is going on here. Okay, these are the most simple equations, and any equation which is not a linear equation is a nonlinear equation. Okay, for example, if you have an equation like this, y equals a to the x cube plus b to the x square plus c. So here the independent variable has powers, the exponents, I mean, other than 1. If it is a linear equation, the independent variable can only have one power. Then we call it linear, no problem. But here, uh, the independent variable has power other than 1. No higher powers or even fraction powers instead of, see, instead of this. Okay, so instead of this, if you have y equal a to the square root x plus b to the x to the 5 plus c. That is also nonlinear. Okay. And another place where there could be nonlinear is, for example, if they have functions a equals to a times logarithm of x plus b times sine of c divided by x. See, a complicated function like that. These are nonlinear functions. Okay, but all nonlinear functions are not a problem. See, in these equations, if you know a, b, c, and x, then you can find y by simply substituting the values of a, b, c, and x. See, in all these equations, if you know the values of if I give you that b is such and such, a is such and such, c is such and such, and x is such and such, what is y? That's an easy thing to do. All you have to do is substitute the values of a, b, and c and x. You can see, for example, in this equation, you get the square root of x, cube of x, multiply with that a, square of x, multiply that with b, and then add this part, that part to another constant c, you get y. Similarly, these are simple operations. So when you could do that, so these three equations, if we know a, b, c, they can be written in a form like this, where y is a function of a, b, c, and x. Okay, if you do that, this is called explicit in y. Explicit in y. What is the meaning of that? The meaning of that is the way this equation is written, or the way this equation is written, it is easy to find y without any difficulty. We can substitute all the knowns and find the y. Similarly for this one, okay. But in this problem, if you want to turn it inside out, for example, if you want to do the inverse problem, in which you know a, b, c, and y, and you have to find x. Okay, is it possible there? Can we write this equation? Can we write this equation such that x is some function g of a, b, c, y? Is it possible that you can simply substitute a, b, c, and y and calculate x here? You think of this. Look at this equation. Look at the last equation. Last equation is y equals a times logarithm of x plus b times. I just made up these equations. Don't worry. C over x. Okay. Can you find x? For example, I say y equals to 10. Y equals to 10. A equals to 1. B equals to 5. C equals to 2. So the equation is 10 equals logarithm of x plus 5 times sine 2 divided by x. Okay. Can you simply get x from this equation? Just by substitution. See, you have the formula, but the formula is what we call this. What this is implicit. This is implicit in y, x. All these three equations, those are implicit in x, because if you have to find x for a given value of other variables in the equation, we cannot simply substitute and get it. Okay, so that is called implicit equation. Now, equation itself is an equation, but in terms of one variable, this equation is implicit. If you want to find y in this equation, it's easy. It's explicit in y. But if you want to find x given a y, this becomes a implicit equation. So what we learn in this module is how to solve such implicit nonlinear equations. Okay, if it is a linear equation, it can never be implicit because linear equations are always straightforward. Okay, it is easy to inverse it. Okay, if you want to find f as a function of t, you say t minus 32 into 18 by 5. Not a problem. So the possibility of an equation becoming implicit, it only comes with the nonlinear equations. So here we solve nonlinear equations, but you have to understand that in this context, when I am saying nonlinear equations, what I mean is equations that cannot be solved explicitly. Okay, so equations that cannot be solved explicitly for a variable, for this context, generally this is a nonlinear equation. But if you are using this equation to find y, you don't need any special technique. You just have to substitute all the values that you know, and then you can easily evaluate the value of y. There's no problem there. But this same equation, if you're trying to solve what the x is going to be for a given y, then you need this. So you need these methods when you're trying to solve equations that cannot be solved explicitly for a variable. Okay. So again, this equation, if you're trying to solve for y, no problem. Look at this equation: square root of x plus b times x to the 5. If you're solving for y, no problem. But if you're solving for x, it is implicit. Okay, you need special techniques. That's what you learn. So I think I have given you some examples here. They usually contain higher powers. I think I'll say not higher, it could be fraction also. So I'll say powers of the unknown, powers of unknown variable other than 1. Okay, and unknown variables and or transcendental functions. When I say transcendental function, when your equation has functions like exponent, logarithm, trigonometric, sine, cosine, tan, cotangent, cosecant, secant, such functions. Okay, those are trigonometric functions. And hyperbolic uh, trigonometric functions, tan hyperbolic, cosine hyperbolic, sine hyperbolic. When you have such functions in your equations, it is possible that there could be implicit. There could be implicit in one or two variables. So there you need that. Okay, equations. Okay, this I think I tried to explain here. Equations may be explicit for some variables and implicit for some other variables. See this very equation I told you, this last equation and any of these equations. If you know x, finding y is easy. Let's say a, b, c are constants. If you know x, finding y is easy. So this is a nonlinear equation, but it is explicit in y. Now, if you have an inverse problem in this equation, again, assume that a, b, c are constants. Okay, you know those values. So this is essentially a relationship between y and x. But if y is given, I'm asking you to find x. It is not a matter of simple substitution. Okay, so the same equation for y it's explicit. Okay, it may be explicit for some variables, but some other variables, in the same equation, x is another variable, but in terms of x, it is implicit. That happens. Okay, so was an example. Do you guys remember this equation? Velocity as a function of time is given as square root of m times g over c d times tan hyperbolic of square root of g times cd over m times t. Do you remember this equation? Does it look familiar to you guys? Anyone?
Sir, remember.
Huh? Yeah. Where do you remember it from?
Bungee jumper problem.
Yes, this is the bungee jumper problem. Okay, so here, we use this in our program also in the first one, wherever, for a given mass of the bungee jumper, for known acceleration due to gravity, for known drag coefficient, uh, we were able to find. I think we used this equation in the program that we did also. For a given time, we calculated velocity. So this is explicit in B. Explicit in B, no problem. If everything else is known, we can calculate velocity, no problem. Now, but if you use this equation in design, a more frequent problem will be not to find velocity. For example, think of this situation. I'm the manager and I'm asking you, in the bungee jumper problem, I'm asking you to find. I'm giving you a requirement. I'm saying that after 10 seconds, when t equals to 10 seconds, I want the velocity of the bungee jumper to be 48. Okay, 10 seconds, 48 meters per second. This is the requirement I'm telling you. Then I'm saying, asking you, the mass of the bungee jumper is 73 kilograms and gravity, of course, is 9.81. I'm asking you, what should be the drag coefficient? Let's say as a design problem, we can choose the drag coefficient. Maybe the bungee jumper, I think I gave you this example, right? For example, instead of bungee jumper, let's say this is just a base jumping. If you know base jumping, that is kind of thing, Ram Charan does in Magadira, not Magadira, that's a old Chiranjeevi movie. Okay, Magadira. So he wants to get to a place at a certain time. So now he can adjust his attitude, like falling attitude, meaning his posture to adjust the drag coefficient. So the question is, he wants to know what is the drag coefficient he has to attain to meet this condition. See, you want to meet this condition. After 10 seconds, Ramcharan wants to attain a velocity of 48 meters per second. And he's jumped off a cliff. His mass is 73 kilograms, let's say, and this is that. Now, he can, he's an expert diver. He can adjust his drag coefficient by doing some maneuvers, let's say. But he has to know what is the drag coefficient he has to assume. He has to acquire. In that problem, you see, this becomes an implicit equation. Now, if I substitute all the numbers here, velocity is 48. He wants to be 48 meters per second velocity. Mass times gravity, that is 73 times 9.81. And CD is the thing that we don't know, hyperbolic tangent, square root of G is 9.81 and CD divided by mass is, we said 73 kilograms. I don't know how heavy he is, but we'll say 73. Okay. Now, see, time is also known, 10 seconds. So in this equation, everything else is known. Only thing is we have to find CD. Can you simply we substitute everything? Everything is substituted. Only there is CD. But can we find CD? Of course we can find, but it's not easy. It is implicit. So this equation, finding for a given time, if you know all the other variables, for a given time, finding velocity was an explicit problem. You had no problem. But if you're trying to design the CD, if you have a specific condition in mind of what the velocity should be at what time, and then you're asking the inverse question of what should be the CDB, what should be the coefficient of drag should be such that the diver attains a velocity of 48 meters per second after 10 seconds after jumping, then it becomes an implicit problem. We cannot simply substitute and solve it. Okay, so that's an example of nonlinear equation. Now, this is only an example. There are many problems, and I'm pretty sure in your first and second year of engineering, you have come across in more than one occasion some nonlinear equations which had to be solved. Okay, I'll ask you this question. Did you come across this kind of equation where even though you substituted all the numbers, you cannot find the unknown? Did this happen to you before? Hello? Anyone? Anyway, well, it is common. Maybe you didn't notice it. It happens. It happens a lot. It's a very common type of numerical problem that we solve. And now we'll solve this equation. Okay, we'll solve this equation. Okay, from what you know now. Okay, here's the thing. Okay, so the equation is this: 48 equals square root of, what did I say there? 73 9.81 CD. 73 times 9.81 over CD tan hyperbolic square root of, I think this is going to be 9.81 times CD divided by 73 into 10. Okay. Okay. Can someone tell me, if I ask you to solve this equation right now, how would you do it? Anyone? If I'm asked, this is the equation I'm giving you. It's a very much a valid equation, a good equation. If I ask you to solve this equation now, my mouse fell on the floor. Okay. 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 So I was telling. Okay. I think you'll not answer like this. I'll call someone. Let me see. I think Maruf is always active. I don't have to worry about that. I think Rashida also. Okay. We'll find someone new that I don't remember. No, I don't. I think all these names are very familiar to me. That Pradyum Sinha, I think he'll never respond. I don't think. Okay, S. Rakesh. Rakesh, you there? Rakesh
Yes,
S.
sir.
Okay, Rakesh. If I ask you to solve this equation right now, meaning when I say solve this equation, what I meant is find a value of CD such that this equation is satisfied. Okay, how will you get that? Hello?
Yes, sir.
Yes, Rakesh. If I ask you to find a value of CD from this
Yes.
equation, how will you do that?
First,
How do you do that, Rakesh?
so transferring the value to the left side, sir.
Okay, we'll do that then. I think you seem to be. Which one do you want to transform? So this part, right? What do you want to transfer to the left side? This one or this one? Rakesh, you went quiet.
Sir,
So which one do you want to transform? Which one do you want to transfer? Okay, I'll show you. I think you're not following the discussion here, but okay, that's all right. 73.981 times 48, it is here. And other side also you have tan hyperbolic of square root of 9.81 CD divided by 73 into 10. See, this is the problem. Now left hand side also has CD, right hand also has CD. Okay, Rakesh, you're not following the discussion because this equation cannot be written. It cannot be written as a function of velocity, time, and what are the things? Mass and g. This is not possible. With this equation, this is not possible. You cannot separate the CD from everything else and write it on one side. That is not possible in this equation. That was the entire first slide I was trying to explain. But I don't know, for 20 minutes, that some equations, they cannot be written like this. Not possible. Such equations are called what? I told you, Rakesh.
Implicit.
Implicit equation, yes. This equation for velocity is explicit. For CD, it's implicit. So forget about that transformation, changing it to that side, that side. You have this equation, and I'm asking you, and I'm telling you, you may not believe it, but I'm telling you, you definitely have come across equations like this. But when they come in the, what teachers do is, we try to avoid problems which end up in an equation like this. So when you're in college, we can do that to keep you safe from these kind of equations. But when you go out in engineering, these are the equations you'll encounter all the time. There is no escape. Your teachers will not be there to you, so that they'll not ask this kind of questions. We try to avoid asking these kinds of questions in the classes because these kind of questions cannot be given in an exam. They're not. You cannot solve this equation in an exam, for example. See, that's why we avoid that questions. But in real design problems, you get equations like this. But even so, I'm pretty sure at least one or two problems like this you have noticed like this in engineering. Maybe in mechanics of solids, maybe in dynamics of machinery, maybe in fluid mechanics. I'm guessing you have come across like this. Either from that experience or using your imagination right now. Can you tell me how you would solve this equation if you have to solve it now? Anyone? Okay, again. Thank you, Rakesh. I'll ask someone else. Rupesh Reddy. So Pawan Kalyan, I think we are enjoying your video now. You're nice, happily lying down in the bed and listening to the class. Pawan Kalyan, can you hear me? Yeah. Yes, Pawan, we can see you. We can see that you're very comfortable on the bed right there. Pawan. Pawan Kalyan.
Yes, sir.
Okay, Pawan Kalyan, from the comfort of your bed, from the comfort of your bed, can you tell us what was I asking? Oh, I forgot the question now. I got so distracted by the kind of jokes I was trying to make. Okay, okay. So how would you solve this equation from your imagination or from your experience of doing it before? How will you find the value of CD here? Pawan Kalyan, how will you okay? How will you find the value of CD from this equation?
Don't know, sir.
Okay, I know that you don't know the formal proper method, but if you have to do it, I ask you that okay, I'll give you 100 rupees if you do it. Then will you say I don't know it? You'll try, right? So how will you try solving it? Okay, maybe 100 rupees not luring enough for you. How about 500 rupees? Then will you put in some effort? What if it is your job? If a manager says that, okay, either you get a value for CD or you don't have your job. Okay, anyway, I don't want to go that. Okay, I'll quickly do this for you again. Okay, today we'll use Jupyter. Okay, because I feel like doing so. So I'll open a new one. Okay, so I was hoping you'd at least say that we use trial and error. Such a simple thing, right? Simple approach. Import math. Okay, so what I'll do is, see, I'll show you. Okay, so we said mass is 73 kilograms, right? Mass is 73. Now what I'm doing is simply trial and error. Simple trial and error. So I'll call this, this approach I'll call trial and error. Okay, so basically you're looking for a value of CD, right? So mass is 73 and G is 9.81. And the velocity you want it to be 48 or 49, whatever, you just make up a number. And after 10 seconds, okay, so the expression, I don't want to type it again. I think I have done it in the earlier class. So I'll just copy it from there. Here, this is the expression. See, this is same. mg over cd square root, that is square root of mg over cd. This is tan hyperbolic, and this is square root of g times cd over m times time. Same equation. So now you want to see, you want this to be 49. Okay, so here you can say, I'll print this value, which is the expression. Okay, or else let me say the trail value, v trail is that. Okay, see, this is now I'll do different trails of CD. I find out what is the value of this one. So I'll print. I'll say, this will print with too many digits. So I'll say print. I'll round it off. VT. And a good place to round off is 5 digits. Let's say 5 digits round off. Comma. I'll print error. Absolute value of V minus VT. Okay, so now I'll try different values of CD. For example, I'll start with CD equals 0.1. See, this is the least. This is what at least with a calculator also you can do this, but it's a little bit more difficult using a calculator. I'll simply run this now. Where did V5 come from? Or VT? Okay, I'll run this. See, I wanted 49, but if I'm using CD of 0.1, the velocity is 69. It is little higher. Okay, At least this much you can tell me. Should I increase the CD value or decrease the CD value to decrease the velocity? Anyone? See, there's only two options. You have 50-50 chance of getting it right. See, I tried a value of 0.1 and I'm trying to achieve a velocity of 49, but I found that if the drag coefficient was 0.1, the velocity after 1 second is going to be 69. But I want velocity after 10 seconds to be 49. Should I increase or decrease the CD? Anyone? Okay, we'll ask some person here. Rupesh Reddy. Rupesh.
Hello, sir.
Rupesh. So will you increase or decrease the CD?
Sir, if you don't mind, I can't hear properly. I mean, I can hear you, but I'm from my side. There is a lot of noise.
Okay, Rupesh, you don't have to be, you don't have to feel sorry for that. You know, everybody has this internet issues, but I'll remember this. I'll ask you some other time. Okay, but you know, this is a common thing. Everybody has.
Yes,
But
sure, sir.
if you are saying same reason again and again, then I'll grow suspicious. Everybody should get one or two chances. It's okay. Okay, I'll come back to you again some other time. Okay, we'll ask Rukmini. Rukmini, you there? Yes, Rukmini, it's a simple question. Please answer quickly. No, it's okay if it is wrong also. See, I'm trying to find a value of CD for which I'll get a velocity of 49. I'm doing trial and error. I tried with 0.1. I got the velocity to be 69. So what will your next trial will be? Will it be more than 0.1 or less than 0.1?
Less than 0.1, sir.
Hello? Hello? Hello?
Sir, less than 0.1, sir.
Okay, thank you, Rukmini. At least you gave an answer, but unfortunately, that is a wrong answer because you will have to increase the. Anyway, we'll do that. I'll show it to you. I'll make it 0.05. I decreased it. You'll see that the velocity will be even higher. What you have to do is increase the drag coefficient. Okay, because more the drag, the body will be coming down at a slower. Okay, now 55. I'll increase it again because I'm shooting for 49. See, now it is less than 49. So it has to be between 0.2 and 0.3. We'll start at 0.25. Okay, now this is 50.85. So we are close to 49. We want to decrease it a little bit. So I'll try 0.26. Okay, I'll increase it a little bit, 0.27. Yeah, see, we are getting there. I'll say 0.275. Maybe two less. I'll say 0.273. Well, see, what I'm doing here is, this is trial and error. But a more proper way of doing it is called scanning. Okay, what we do in scanning is, okay, I think you understood trial and error, right?
Yes, sir. Understood.
Yes, thank you very much. So what we do in scanning is,
Yes, sir.
instead of doing it randomly like this, okay, we do it properly. We have to first of all rewrite the equation. As I'll show you how I type the equations. You use the dollar signs and then f of root equals 0. Okay, then what we do is, for each in scanning, we take small steps. Here I kind of did trial and error, random, okay. But here you start at a point. What I'll do here is I'll say, no, we'll take the same numbers. Okay. And then see, important thing is we have to rewrite the equation as function of root equals to 0, meaning I have to bring everything to one side. See, and that one side is called f of r. In this case, I think I'll do it cleanly and I'll send it to you. But for I in range, we'll do for 100. Okay. Then I'll do this 100 times. Okay, I'll tell you this. See, our expression was velocity equals this. This is our expression, right? This is our equation. Now what I'll do is I'll say this minus this should be equal to 0. So same equation, if you write it, it will become like this, right? But what we look at is only the left hand side of the equation, which is this. This is our f. If you bring left hand side, both sides to one side, both of the expressions on either side of the equality, if you bring them to one side, and then we are calling that expression. When you bring it to one side, whatever that expression is, that we are calling is a f of r. In our case, this is f. Is f. And now we are trying to find r, the root. In this case, root is in terms of CD. We want to find a root such that this function value becomes 0. We want this function, see b is already there. So we want this equation to be 0, this expression to be 0. We have to try to find out. So I'll do that. I'll do exactly that. And I'll print, for each case, I'll print CD, comma, f. For the next iteration, we'll change the value of CD. CD equals 0.001, let me say. I'll start with 0.2. It's okay. I'll start with 0.2. Okay. So that is called scanning, and I'll show you what it is. Oh, this is capital CD. See, I think I should have been careful. This is CD plus equals to. I told you about the increment operator. What this means is, this is incremental assignment. It's called augmented assignment or something. CD equals CD plus 0.001. That's what that means. Okay. Now I run this. See, this is the round-off error kicking in because it's supposed to be 0.205 anyway. See, we have separate values 2, and it's negative, and here it's becoming positive. Okay, so between 2.273 and 0.274, there is a value. See, the root is here. It will be between 0.2. This is scanning. Okay, I think so that it looks neat, I'll do round up again. Round. Okay, I'm sorry. I think I forgot. I think the time is up. Okay, so there. Let me simply run this one and I'll stop it there. See, so I have made a table. This is called scanning because we are going one step at a time. 0.2, 0.201, 0.202, 0.203, 3, 4, like that. We are looking for the root. Where is the root? And this you could do because this is a computer program. It can do 100 calculations. See here, in a matter of in a matter of milliseconds, I have tabulated a value, the function for 100 different values of CD. And from this, I can see that for CD values below 27, or where is okay, for CD values below 0.273, the function value is negative. Above 0.274, the function values are positive. So between 0.273 and 0.274, there will be a point where the function value has to be exactly 0, and that is your root. Okay, and this process is called scanning, and I'll continue from here in the next class. Let me simply get attendance. Who is the teacher for the next hour? Any questions so far?
Akhil sir.
Which class? Anyway, any
English
questions
sir.
so far?
English sir.
Yeah, I'll quickly get attendance. Any questions so far? Okay, I'll stop the recording and also